The observable universe spreads across and expands so big that it warps the imagination. Although there is a cosmic boundary that we can see, many astronomers believe that there could be much more out there in the darkness, billions and billions of light years away. And it seems there is something strange and mysterious out there with an immense gravity pulling on everything. What is that exactly? And how did we know that? Watch this video until the end to get the answers. So let's begin. Space is expanding at an accelerated rate, and giant space structures farther that we can see could be out there, tearing space apart. And we may have seen one of these in our own universe. The universe is larger than we can comprehend. Currently, we know there are at least 100 to 200 billion galaxies out there, which we can now see. But it's a good chance there could be over 2 trillion galaxies or more in the observable universe alone. We just can't see them. We all know that the observable universe is estimated to be approximately 13.7 billion years old. This is defined by the speed that light travels. And astronomers came up with the age of the universe by measuring light that has reached us from the oldest and most distant stars. We define observable space by the light that has reached the Earth and can be seen. Cosmologists estimate the oldest photons that we can currently see have traveled a distance of 45 to 47 billion light years since the hotly debated Big Bang theory. This means that our sphere of observable universe is around 93 billion light years across. To give you an idea of how big this really is, 1 light year, which is the unit of astronomical distance that light travels in 1 year, is 9.46 trillion kilometers. With that in mind, the big question is, how can the universe be 93 billion light years across if it's only 13.7 billion years old? This means that the universe could be much older, much more than 14 billion years. We know that anything further away than the light we see from the beginning of the universe or the cosmic Big Bang has not had enough time to reach us. Thus, we can't see what's out there. It's pitch black. But does that mean the edge of the universe we can see is all there is? The truth is there could be a lot more out there. Ever since the Big Bang, the cosmos has been growing at an increasing rate. It was Edwin Hubble who discovered that the universe is expanding and that galaxies are moving away from the Milky Way. Not only are these galaxies moving away from us, but the farther away they are, the faster they are flying away from us. In fact, Hubble found that for each additional megaparsec of distance, the galaxies receded 500 km per second faster. This became known as the Hubble constant, and the area of our observable universe is called the Hubble volume. One thing we need to understand is that the word observable in this sense doesn't refer to the capability of our current modern technology to detect light or other information from an object, or even if there is anything to be detected. Observable here in this case refers to the physical limit of the speed of light itself, which is its maximum speed. When talking about the distance of anything in space, we are also talking about the time. Looking up into the night sky is a little bit time traveling. All those glittering stars in the night sky are only snapshots of what those stars looked like in the past. Just think about it. Some stars and other objects in the cosmos are so far away that their light can take thousands to millions of years to reach planet Earth. And if there is something beyond the edge of the observable universe that we can't currently see, it means that these objects are so far away from us that their light still has not reached us. The cosmic horizon is the measure of the distance from which we can retrieve information. But is there something out there past what we can see? It's really tough to answer this. However, to get some idea if there is something out there, we need to take into consideration the curvature of the observable universe. The thing is that astronomers aren't really sure if the universe is infinitely big or just vastly huge. In order to measure the universe, astronomers look at its geometric curve on large scales, which tell us about its overall shape. If the universe is perfectly geometrically flat, then it can be infinite. But if it's curved like Earth's surface or is like a bubble, then it has a finite volume. Current observations and measurements of the curvature of the universe show that it's almost perfectly flat, like a sheet of paper. That would indicate that it must go on forever. We know with some certainty that there is more universe out there beyond the boundary that we can see. Astronomers believe that space could be infinite with more of what we already see, and it's probably distributed the same way as it is here in the observable part. Now here is one of the mind-blowing things to think about if the universe is infinite. If it were to be true, then you wouldn't just find stars, different planets and galaxies, you would eventually find every possible thing. You would find everything. If you went far enough, you would find a solar system identical to ours in every way, including a planet Earth and your twin. It's a fact that some cosmologists think if you go far enough, you would eventually find another Hubble volume that is identical to ours with a version of yourself mirroring your every action. Now, while that might sound impossible to what your minds can grasp and understand, there is something else very strange and unexpected that was discovered by astronomers in 2008. They found that galactic structures were all streaming in the same direction at over 3.2 million kilometers per hour. It is a phenomenon called dark flow. This movement of galaxies defies all predictions about the distribution of mass throughout the universe after the Big Bang. So what is the mysterious gravitational pull on these galaxies? One possible cause could be massive structures that are outside the Hubble volume that are exerting a massive gravitational influence. In simpler terms, massive objects with a huge gravitational force pulling everything towards them. If true, this would mean that the structure of the infinite universe beyond our view is not uniform. No one knows what these structures could be. It is possible they are accumulations of matter and energy on scales we can barely comprehend. Or they could be gravitational forces of other universes. Speaking of massive structures, there is one in our own universe that is so big that it shouldn't even exist. In fact, it is the biggest structure in the observable universe. It is called the Hercules Corona Borealis Great Wall, and it measures 10 billion light years across. It is so big that it makes up 11% of the observable universe. To put this further into perspective, if you were traveling at the speed of light, it would take you 10 billion years to get from one end to other. So why shouldn't it exist? The problem is that astronomers have no idea how this Great Wall formed only in a few billion years after the Big Bang and could have grown so big in such a short time. This means there could be giant structures like these out there pulling on everything, including space. And speaking of gravitational forces from other universes, some astronomers believe that the post-Big Bang expansion of the universe created bubbles that formed the structures of space. And each of these bubbles is an area that stopped stretching along with the rest of space and formed its own universe with its own physical laws. In this scenario, not only is space infinite, but each bubble is also infinite because you can store an infinite number of infinities inside a single infinity. To make that seem a little more clear, even if you could breach the boundary of our bubble, the space in between bubbles is still expanding. So, in the reality of space-time, you could never get into the next bubble, no matter how fast you traveled. But will we one day have the technology to see what's beyond the edge of the universe we can now see? The sad reality is that light from any object outside the Hubble volume will never reach us because the space between us and it is expanding too quickly. For example, we may never see what a galaxy looked like 10 billion years after the Big Bang. This doesn't have anything to do with our limited technology, but instead the physical limits of the speed of light itself. This means that any light-emitted objects at a distance of 19 billion parsecs will never reach the Earth. As time goes on, more and more points in space will have time for their light to reach us, which means that the observable universe is still increasing in size, and that also means that the age of the universe will increase. That said, you might think that one day, if humanity is around long enough, the entire universe would become observable to us. But since space in the universe is continually expanding, the distance between us and everything else becomes farther and farther each second. However, the James Webb Space Telescope will be able to look further into space and will look backwards in time, and just may give us more answers to what else exists out there. In a sense, it is a time machine and will be able to see further into the past. The telescopes in the history, along with giving answers, raised other confusing questions. So, the James Webb Space Telescope may even give us some more questions to find answers to. If you liked the video, hit the like button, smash subscribe and hit the bell for more such videos. Thanks for watching and see you in the next video.